Today, we're gonna dig into the hidden world right beneath our feet. Seriously, we're gonna explore the super precise science that tells us what's really in our soil and why that knowledge is just absolutely essential for growing the food we all eat. It's kind of a weird question, right? How much food does your food need? But when you think about it, every single plant out there needs to be fed. And the biggest challenge for farmers everywhere is figuring out that perfect meal plan for their crops. And you know, the main course on that menu is always nitrogen. It's totally essential for plant growth. But here's the puzzle. Getting it wrong has some serious consequences. If you have too little nitrogen, your plants basically starve and crop yields plummet. But if you have too much, you're not just wasting money on fertilizer, you're risking environmental damage as all that extra stuff runs off into our water. It's this classic Goldilocks problem, you know? It has to be just right. So how in the world do you solve a problem like that? Well, you turn to science. The solution is a really precise, standardized procedure called the Kajolda method, and it is how we take all of the guesswork out of farming. So what is it exactly? Well, the Kajolda method is a classic chemistry test that measures the available nitrogen in the soil. And that's the key word, available. It's the specific kind of nitrogen a plant's roots can actually absorb and use. It's the only number that really matters for a healthy crop. And here it is. This is the toolkit for our nitrogen detective. I know, it might look a little complicated, but every single piece of this glass setup is meticulously designed to do one thing and one thing only. Pull the nitrogen out of a soil sample so we can measure it with incredible precision. Okay, so the whole process kicks off with step one, creating a very specific chemical recipe. This is really the first step to unlocking what the soil is hiding. And let me tell you, precision is everything here. We start with exactly 5 grams of soil. To that, we add a measured 25 milliliters of potassium permanganate solution, which is a really strong oxidizing agent. Then we add precisely 40 milliliters of a strong base, sodium hydroxide. Every single one of these measurements has to be perfect because the final result totally depends on it. So, once our sample is all mixed up, we move on to step 2, distillation. This is where we use heat and a little chemistry magic to separate that nitrogen from everything else in the soil. So inside this first flask, the mixture is gently heated up. This kicks off a chemical reaction that converts the nitrogen that was locked in the soil into ammonia gas. We're essentially turning a solid nutrient into a gas that we can then capture and measure. Pretty cool. Now, that ammonia gas doesn't just float away. It travels through all that tubing and bubbles into a second flask. This one contains 40 milliliters of boric acid. Think of it like a chemical trap. As the ammonia gas gets absorbed by the acid, it actually changes the pH of the solution, which causes a chemical indicator to turn it that really distinct blue color. And this process is super controlled. The distillation runs for either a set time, 10 minutes, or until we've collected 100 milliliters of liquid, which is called distillate. And that bright blue color in our collection flask, that's the signal, the proof that we've successfully captured the nitrogen. So we've captured the nitrogen, which is great, but we still don't know how much we have. And that brings us to the final and honestly the most dramatic step of the whole test, titration. This is the moment of truth, where we make the invisible visible. We take that blue solution we just made and we start adding a weak sulfuric acid from this long marked tube called a burette. And we do it so slowly, drop by single drop, just watching and waiting for a very specific signal. And there it is. The second that the last bit of ammonia is neutralized, the solution just flips. It makes this sudden, dramatic shift from blue all the way to pink. That color change is our stop sign. It tells us the test is done. We then look at the side of the burette and we record exactly how much acid we used. It might be a tiny number, something like 1.5 milliliters. I know it doesn't seem like much, but this single measurement, what the procedure calls reading C, is the most crucial piece of data we've been working to get. Okay, so we've gone through this whole meticulous lab procedure, but what does it all mean? How do we take this result from a little beaker in a lab and turn it into something that's actually useful out on a huge farm? Well, we do it with this formula. Now I know this looks intimidating, a whole lot of math, but really it's just the engine that translates our lab work into a practical number. See that C minus B at the very beginning? C is that tiny measurement we just took from the titration. Every other part of this equation is just there to convert that tiny volume into a real-world, large-scale agricultural metric. So, to put it simply, its entire purpose is to be a translator. It takes the milliliters of acid we measured and it calculates the total kilograms of available nitrogen per hectare of farmland. That's it.
That final number is then just compared to a standard chart, just like this one. So if our result was, let's say, 250 kilograms per hectare, we can easily see that it falls right into the low category. This simple rating, low, medium, or high, is the clear, simple answer the farmer was looking for.
And that rating connects directly to a specific action. A medium rating, that means just use the standard amount of fertilizer, but a low rating tells the farmer to bump up the dose by about a third. And a high rating, that means they can safely cut back and save money. The guesswork is completely gone. So let's zoom out for a second. We've just walked through a really detailed, really precise chemical analysis. Why does all this careful, meticulous work in the lab actually matter in the big picture? Because it is about so much more than just a number. This single test gives farmers the power to make smart, data-driven decisions. It helps ensure our global food security by making sure crop yields are as good as they can be. It prevents the waste of money and precious resources. And so importantly, it helps protect our environment from the damaging effects of using too much fertilizer. So, maybe the next time you're driving past a beautiful, thriving green field of crops, you'll see it a little bit differently. Maybe you'll think about all the careful science and the hidden chemistry happening in the soil that made it all possible.